In this video, we're going to look at all the different ways in which we can sketch sine and cosine circular functions. This includes starting with just the dilation factors a and n, and then we move on to some of the more complicated examples like how we handle horizontal translations and how we handle vertical translations. Enjoy! Let us begin. So the agenda for this one is to review, I believe this is the second time we've had a look at it, sketching sine and cos. Or at least the second time in the group classes we've had a look at sketching sine and cos. So what we're going to do is have a look at each of the three different kinds of scenarios you run into, one of which is when you just have the a and n terms that are associated with it. The other is when you have horizontal translations, and lastly is when you have vertical translations. I think the way we'll do this one best is we'll do one example of one. We go into the textbook, do an example live together on that one, and then rinse repeat. Basically jump between pre-written examples and ones that we do together. So first up, what are the graphs of sine and cos? Well, the graph of sine looks like this. The graph of cos looks like this. Very, very similar. Now, the only difference slightly between them is where they start. So if you think of their starting location as at x equals 0, you know that sine is going to start specifically at the origin, wherever cosine or cos starts at its peak. They both have this wave-like pattern. What you'll find is that without any other transformation factors, that pattern will repeat every 2 pi. So this distance here from 0 to 2 pi, you see it goes from the middle, up, middle, down, and then returns back to the middle. We've completed one full cycle from 0 to 2 pi. Exact same thing can be said here. It's gone from the top, middle, down, middle, and then back up to the top, all within 2 pi. Peaks and troughs, without any transformations, they're both going to occur at plus and minus 1. So this is a peak, this is a trough, as far as the y values are concerned, 1 and -1 respectively. Those are the fundamentals there. As for the specific factors that might change that, the first is the a value out the front. So for example, if that a value was 3, what happens is instead of peaking and troughing at plus and minus 1, it's now at plus minus 3. So that peak now has a y value of 3. This trough now has a y value of -3. As for n, so that's going to be the value that's directly attached to the x, that is a dilation factor that stretches you horizontally. As that number gets bigger, the horizontal stretch starts to, it shrinks actually as this number gets bigger, which is why instead of doing a full cycle from 0 to 2 pi, we now do a full cycle of peak, middle, trough, middle, peak. That full cycle only happens within pi this time. A few key takeaways here. So you'll find that the a value out the front is often referred to as the amplitude. It's worth pointing out a specific nuance here because it does get tested and you will get it wrong if you don't get this nuance. By definition, the amplitude is the distance between the peak and the mid-level of the circular function. So what I mean by the mid-level is like this spot here. It's the middle between the peak here and the trough here. If you average out those y values, you get into the middle there. So by definition, the amplitude will only ever be this distance, or this distance, or this distance. Point being, that can only ever be positive because it's upwards, it's pointing upwards. Whereas anything like this could be negative, right? That is not amplitude anymore. Amplitude can only be positive, whereas this a value could be positive or negative. That's the only nuance to keep in mind there. If I need to explain that any further, either raise your hand or give me a question in the chat, however you want to do it. As I said, n value is responsible for stretching horizontally. Now, more specifically, what it can be used in is calculating the period of the circular function, which by definition is the distance covered in the x direction before the circular function repeats once. So we saw that before, right? That's how long it took to repeat the pattern from 0 to pi. You don't always have to necessarily start at 0. That's why it had a more specific definition. We could have started at pi and looked at it from there. That's gone from pi to 2 pi. Still a total distance of pi was covered. The way you calculate it is 2 pi divided by n. So whatever that coefficient is on the x, in this case it was 2, that's your n value. 2 pi divided by 2 is pi, and for that reason, 0 to pi is one cycle. Last thing to keep in mind, all of the key features of the graph, so we're talking the peaks, troughs, and mid-levels, so this, and this, they all occur at quarter period intervals from each other. And we'll see what that means with an example. Okay, so this is one where there's just an a and an n term in it. A equals 2, n equals 3. These are the steps we follow. Let's take a look at what that gets us. First things first, find the period of the circular function. This is going to allow us to actually sketch the circular function. How long does it take to do its cycle? In this case, n is going to be 3. So when you do your 2 pi divided by n, you're in fact doing 2 pi divided by 3. So that means our period, or the one cycle, is going to start from 0 and end at 2 pi on 3. Next up, peak and troughs. Those are going to occur at plus or minus a. So in this case, a is 2, so the peak is going to be 2, the trough is going to be minus 2. Sorry, I have to just swipe a bug off my screen. That gives us our peaks and troughs. From there, we're going to divide up that period into 5 equally spaced x-coordinates. That's going to be giving us all of these key features here, like the actual physical x locations of those. So if we're starting at 0 and ending at 2 pi over 3, one of the ways I like to do this division is simply just halve, and then backfill. So if you look at what that would look like, you would start by drawing your 0 and 2 pi over 3. Halfway on that interval will be half of that, so 2 pi over 3 becomes pi over 3. And then halfway on this interval is this one, pi over 6. When you half, and half again, you get to a quarter. The only thing that's left is you have to backfill here, but once you get to this value, you already know what that number should be. It's just pi over 6 plus pi over 6 plus pi over 6 plus pi over 6. So this one here would simply be pi over 3 plus pi over 6, which, when you simplify, gets you to pi over 2. Now, I did say to split it into 5 equal x-coordinates. The thing to keep in mind is that 0 counts. You got 1, 2, 3, 4, 5. From there, all we're going to do is figure out where the y values go. And that you do by just referring to whatever the generic cosine or sine is. In this case, we had cosine, and cosine always starts at a peak. So its 0 value should be whatever the peak is. This is the generic one. Our peaks occur at plus minus 2, right? So we know that at 0, we have a peak. Our peak being 2 means we put the coordinate 0, 2 as our starting location. Then we just follow the pattern. So the next thing should be a middle. So that next little tick that we drew is going to be the middle. Then the next thing should be a trough. Then the next thing should be a middle. Then the next thing should be a peak. And you just keep going left to right with all those little ticks that we drew. From there, you just draw as smooth of a curve as you can. I often find whenever I draw it, a lot of it is like wider here and then bunched up here. Me drawing all these ticks is in an effort to try and make it not look that shit, but sometimes that's just what happens. So as long as you're getting something that is vaguely wave-like, you'll be fine. That's that one. Any questions on how that came about? Let me know. In the meantime, I'll grab a screenshot of the steps we follow. Okay. Now we're going to do it live. So let's give one of these a shot. So kind of similar scenario here. For A, we're going to do 3 sine 2x. We're going to try and sketch that. Y equals 3 sine 2x. All right, now here's the fun part. You guys are going to have to tell me what we do. So I'll give you a screenshot of the steps that you follow. What does the first step require us to do? And if you know that, what is the answer for that first step? Find the period, which would be pi. Okay, so that's correct. Yeah, we find the period. Capital T is 2 pi divided by n, and in this case, n is going to be 2. That's why it becomes pi. So capital T, 2 pi divided by 2, capital T is equal to pi. Yep, that's good. All right, that's step 1 down. What else do we need to do? Peak and trough, plus minus 3. Yeah, precisely. So yeah, next step was peak and troughs are going to be plus minus the A value, which sure enough, there it is, plus minus 3. So peak, in fact, yeah, let's just put it on axes. Why not? That is the furthest thing from a straight line possible. There we go. Okay, got 3, got minus 3. What do we do once we have those? In fact, I could even draw the pi out here. Do the scaling, which would be pi on 4. Yes, it would. Yeah, so this is where we get those little intervals out. Pi, halving that gets you to pi on 2, halving that gets you to pi on 4, and then backfilling would be 3 pi on 4 there. Reminder that you've got the 0 there as well, which is why we have our 5 key features. Yep, and then finally we just got to dot it all out. So we have sine, so where does sine start? Peak, middle, or trough? Middle, absolutely. So middle it is. And then because it is positive sine, are we going to peak or are we going to trough afterwards? Peak, yeah, absolutely. Then the rest, well, it becomes pretty chill to dot out everything else. Dot, 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 dot. Draw the curve as best you can, and let's see how it came out. Yeah, would you look at that? It looks like it's actually a circular function. Nice. All right, I take it those are pretty chill. Does anyone want to see another example of that, or are we happy to move on? We did kind of fly through that, yeah. Alrighty. Next up, reflections. So reflections work the same way as they always have, where if the negative sign is out the front of the function, it is a flip vertically, so across the x-axis or about the x-axis, which is why sine's still going to start at 0 because negative 0 is still 0. But instead of going to a peak, it's now going to go to a trough and then continue the pattern from there. For cosine, same deal. Used to be a peak, now it's going to be a trough. And then horizontal translations. So horizontal translations work again, as they always have. Minus a value means a shift right by that thing. In this case, pi over 2 to the right. And in this case, pi over 3 to the left because of the plus there. All that really does is change up the section when you're doing the scaling. And so instead of just scaling it directly by going from period divided by 4, you now have to adjust those x coordinates by whatever that horizontal translation is. So in this case, we have a shift forward by pi over 2, which is why, well, I guess right by pi over 2. So every single one of those x values that we found in this example are going to get shifted forward or to the right by pi over 2. But otherwise, everything else, well, sorry, almost everything else is the same. What we find is that for certain horizontal translations, you may also need to additionally find a y-intercept, depending on your domain. Like this domain here didn't touch, so we didn't need it. This domain here did touch, so we do need to now find this. That doesn't happen if you don't have a horizontal translation. Your y-intercept, if you have no horizontal translation, will always be one of those key features, which is why we didn't need that last time. But okay, in this case we've got 3 sine x minus pi over 2, period 2 pi over n, so in this case n is 1, giving you period 2 pi. Peak and trough, same thing as before. Quarter up the period, so that's 2 pi, half to pi over 2, and that sticks that 3 pi over 2 from what we knew from before. Now here's the interesting bit. We had a shift right by pi over 2, which means all of these values go right by pi over 2. This one was kind of lucky because everything's already in base of pi over 2, or a factor of pi over 2, so you can very quickly just say the 0 goes to the pi over 2, the pi over 2 goes to the pi, and they just keep like filling over each other until this 2 pi bit, which goes out to 5 pi on 2. And then yeah, you just go from what we did before. Sine starts at a middle, then goes to a peak, and then continues that pattern from there. So now your starting location is whatever that horizontal translation was. If it was shifted backwards, or if we had a different domain, we'd have to find our y-intercept. If you do need to do that, you just sub in x equals 0. This is what you do when you're evaluating a circular function. For instance, if it's like sine of 0, you have to look for where the angle is 0, and sine of 0 is also just 0. Same idea here, just sub in x equals 0 if you need to. About it, really. Anything to clarify further about how horizontal translations work? Okay, screenshot is incoming, and we'll give one of these a shot. All right, let's see. What's a decent one to do? I think we just did that as an example, actually. Where's a better one? Yeah, let's do a cosine. Let's get that one. So, going to have... Uh-oh. Why can't I draw? That's really weird. Have I run out of space on my... That's funny. I need to create a new note. I've exceeded everything in OneNote. No worries. New note. That's crazy. I've never done that before. Okay, let's try that again. Y equals, yeah, cosine. So 2 cos 3. Theta plus pi on 4. It's worth pointing out, in the book, they write this really weird. They write this without that set of brackets on it. It means the same thing. So with these brackets versus without, those brackets mean the same thing. I don't know why they insist on not putting the brackets there. Maybe because it looks a bit, I don't know, too many brackets, but anyway. So, what are we doing? How do we start this one out? Find period, and the period is 2 pi on 3. Yeah, because our n value is 2 pi on 3. Just because there's a theta there doesn't mean anything different. Theta is basically just a stand-in for x. Capital T equals 2 pi on n, where n is 3. Nice. What else? Peak and trough plus minus 2. Yep, that's it. Once again, a value is 2, so peak and trough are going to be at plus minus 2. Oh, maybe I should pull this forward a little bit. When there's horizontal translation, it makes life a little bit more difficult. Yeah, so we tick those out. I'm going to have a 2 here and a -2 there. And 2 pi on 3. All right, what are we doing from here? The horizontal translation on 4, pi on 4 units to the left. Yes, it is shifting pi over 4 to the left, so you can put that down first. Nothing quite wrong with that. So minus pi on 4. What do you do from here? Add the intervals? Yeah, we do have to add the intervals. You've kind of done it not wrong, but just different to what I've described. You can do it this way. The way I described in the notes was to ignore this for now and do the quarter period, those interval ticks like you've done before, which would be 2 pi over 3 becomes pi over 3 becomes pi over 6, and then pi over 2 goes in here, and then shift all of those back by pi over 4. The alternative, and that's nice for like a little picture because it shows you how it's good for a picture, basically. How I actually do this in reality is I don't put this on the interval. What I do is I quarter whatever this is. So I would say quarter period is pi over 6. And then I look at whatever my translation is, which is what you brought up before, which is that shift backwards by pi over 4. With that in mind, I start at that translation term, so that minus pi over 4, and I repeatedly add this quarter period until I fill out the domain. So basically, I want to get 5 ticks out of it, 5 interval ticks. Now that becomes a bit challenging because you've got a pi over 6 here and a pi over 4 there. Adding pi over 6s to pi over 4s kind of sucks. So to make up for that, let's do this in green actually. You get the same denominator. So you got negative pi over 4 plus pi over 6, because you want to keep adding quarter period intervals. So that gives you negative 6 pi plus 4 pi on 24. So in this case, you got negative 2 pi on 24. And I would actually keep that there for a little bit until you fill out your 5 spots. So you got 1 here, you got 2 here, and you now know that anytime you add pi over 6, it's the same thing as adding 4 pi on 24. So the next one would be adding 4 to that. You've now got 2 pi on 24. You add another 4 pi to that, you got 4, 5, 6 pi on 24. 1, 2, 3, 4. We need 1 more. That gives you 10 pi on 24. And then at the end, you can just sort of simplify all these down. So that's your negative pi on 12. That's your positive pi on 12. This one's 3 pi on 12, which becomes pi on 4. And then 10 pi on 24, 5 pi on 12. And once you have your 5 ticks, you've got at least 1 cycle, which you're now happy with. Okay, so negative pi on 12 would put that. Yeah, maybe I should expand this out a little bit more. So if I go tick 1, 2, 3, 4, 5, we had that negative pi on 4 from before, minus pi on 12, plus pi on 12, pi on 4, and then lastly 5 pi on 12. Cool, got all those down. So you can see how horizontal translations can be a pain if they're different denominators. Is there anything about that I should clarify? Otherwise, let me know what the next step would be. Find the y-intercept. Yep. So how do you find the y-intercept? Same way you do the y-intercept for any other graph. How do you do it for any graph? Uh, it would not just be the amplitude here. So yeah, to describe that again, if I show the picture on the screen share one more time, well, maybe even this one actually. Wait, no, that one went forward. We want one that goes backwards. So you can see in the picture on the screen share, that one didn't actually end up being on the amplitude. You can see that as it cuts through the y-intercept, it's on its way up, or I guess on its way down, depending on if you're looking at it from the left or from the right. Since it's on its way down at that spot, horizontal translations really throw that off. So under those circumstances, that's why I've got it in the notes that you, well, I guess I didn't actually. I didn't say to solve y-intercept by setting x equals 0. I did just say solve y-intercept. Maybe I should fix that up. Yeah, I'll just write myself a quick reminder to say x equals 0 on that. Y-int circ. Yeah. So yeah, we are just going to do x equals 0, or in this case, theta equals 0. So what that would end up looking like, it was 2 cos 3, 0 plus pi r 4. 2 cos 3, 0 plus pi on 4. That's going to give us 2 cos pi over 4 times 3, so 3 pi over 4. Does anyone remember what cos of 3 pi over 4 is? Root 2 on 2. Yeah, precisely. So that's your 3 pi over 4 spot. It's that quadrant 2, which is why it ends up being the root 2 on 2. Yeah. So you got 2 out the front of root 2 on 2, which sure enough, the 2's cancel down, giving you a y-intercept of root 2, which makes sense. So we can put our root 2, let's say there, why not? Close enough. What else do we need to do to finish this up? Oh, wait, sorry. That does feel a bit weird. 3 pi over 4. 3 pi over 4 being that spot, cos being the x. There is something slightly off about this. What did I miss? Yeah, negative root 2 on 2. Yeah, I missed it too, don't you worry. So yes, negative root 2, final answer. And you, in practice, you'll never actually get this wrong. Because let's just for now not even put it on the axes. If I were to start dotting this out, how do I start dotting this out? Like for example, what's my y value at negative pi over 4 going to be? We're cos this time. Sine would have started at 0. Cos starts at what this time? 2. Yeah, that's good. Cos starts at a peak. and then, well, the pattern becomes obvious. So you'll find that as you dot everything out, you actually can't get the y-intercept wrong as far as if it's positive or negative, because when you draw everything out, you'll be like, hang on a minute, how do I have a positive number but my graph goes through like this? So it's got some sort of inbuilt error checking in there. You know that negative root 2, can't really squeeze it in. Let's try anyway. There we go. Negative root 2 should actually be negative rather than being the positive. So that's what caught me out there. I was looking at this and thinking, positive root 2 doesn't really make sense for this graph. So that's a nice little way you can do some error checking from that. But otherwise, yeah, that is that. Anything to clarify further from there? Let me know. All right. Last up, vertical translations. So these can either be really, really nice or really, really sucky, depending on how big the vertical translation is. If you have a +2 in this instance, or basically if you have any translation which gets you entirely above or entirely below the x-axis, it's really cool because you don't have to solve any of those spots anymore. It's just sort of floating there. The way it works, vertical translation, you can think of it as repositioning where the middle of your circular function is. So normally sine would start at 0, 0. So it normally starts down here. The +2 means it gets shifted up by 2. Again, vertical translation works the same way as it does for any other graph. Similar thing here, cosine minus a half. You'll now see that minus a half is the new mid-level of that circular function. Plus or minus 1 from that gets you to a half and minus 3 over 2, respectively. So one of the key things you find with, yeah, I thought that was off for a second. One of the key things you find with vertical translations is now, did I not? Yeah. Now it increases or changes where the peaks and troughs are going to occur. So the first thing is now peaks and troughs are at C plus or minus A. C because C is the vertical translation, it sets the middle, and then plus or minus A from that. Plus, minus. That's one of the things. That's not so bad. This is what's bad. Because if you look at what happened here, you've got your interval ticks, the quarter period interval ticks, where it's like peak at 0, middle at pi over 2, trough at pi, so on and so forth. But now you've got these two things to solve for, which doesn't look like a lot. You're just solving for 2 spots, but it's a bit time intensive. You do that the same way you solve any x-intercepts, by setting y equals 0. So let's look at an example. So in this case, I'm not going to have any horizontal translation, although you absolutely could have both. You just basically combine the two approaches. But okay, sketching this, first up, find the period, super easy. Peak and trough, again, you're now starting at whatever the vertical translation is, and you're doing plus or minus this value, giving you a peak of 3 and a trough of -1. From there, divide up your interval. In this case, it was 2 pi, and there's no horizontal translations, so it's pretty chill. Same thing as you're already used to. And then because it's a sine, what is it actually? Yeah, we're cos. So we're specifically negative cos, actually. Cos usually starts at a peak, but because it's a negative cos out the front, it's going to be -1 there, because that's our trough value. But otherwise, yeah, continue the pattern as normal. Draw out the curve, and when you draw out that curve, you'll realize that you have these to now find. So from there, all you do is, again, as I said, set y equals 0, and then solve. This one was pretty nice. If you have horizontal translations, if you have dilations, anything like that that will cause you to have multiple cycles, it's just a bit annoying, but that's the game. So yeah, set y equals 0, subtract 1, divide -2. You just need to figure out where is cos equal to a half, and that once again requires you to be familiar with your unit circle. Cos is equal to a half at pi over 3 and 5 pi over 3, and there's also some inbuilt error checking in here as well. Like if you see that your line goes through here, and you say a number that's bigger than pi over 2, you should check that again. Or you should check your curve, just in case you put the curve in the wrong spot. One of the things is going to be wrong if your number doesn't seem to line up. That is not as complicated as it could get. Obviously, you could have both a horizontal and a vertical, but we've now seen all different scenarios that could come up, at least individually. I'm pretty sure in Unit 1 and 2 it doesn't actually get to doing both, but in Unit 3, 4 it does. Let's see. Oh, did I go too far? Probably. No, it actually does. Does both here. So let's see. Yeah, we should have enough time to do both. We can do one where there's no horizontal. We can do one where there is a horizontal. But before that, should I clarify anything we've gone through thus far? I've got a screenshot going. Alrighty. Yeah, this one should be fine. Okay, so we're going to have y equals 2 sine x plus 1. What shall we do? Period of 2 pi? Yeah, that's it. Capital T period is 2 pi divided by n, where n is 1. Period is going to be 2 pi. That's good. What else? Peak is going to be 3, yeah, because of the 2 plus 1. That's good. So it's always whatever this is, plus or minus whatever that is. So yeah, peak's going to be 3. What else? Prof is 1, yeah. Well, hang on. 1 plus 2, 1 minus 2. Nah, 1 minus 2. So you got a middle of 1 here. So it's not the 2 minus 1, it's 1 minus 2 for this one. That'll get you down here. Fair enough why that is? Sweet. Okay. And then yeah, I kind of already gave the middle in there. So we knew we had period 2 pi. Where do we go from here? How do we find the middle? The middle is always whatever the vertical translation is. So in this case, it's 1, which is why we put a middle of 1 there. Yep, no worries. Now we need the intervals? Yeah, absolutely. So a couple ways you could do that. Name one, I guess. Divide it up, yep. So 2 pi becomes pi, and then pi becomes pi over 2. Backfill 3 pi on 2. That's good. Okay. Next up, we got a step 4 there. Do we need it? Yeah, correct. Nothing. No horizontal translation. All right. Next up, finding y values. So yes, starting from 0, do the dots. Absolutely. So given that it's sine, what should the y value be at x equals 0? So normally it's 0. Yeah, sine regularly is 0. I think a more nuanced, yeah, now it'll be 1. Correct. Normally sine is 0. Because it's been shifted up by 1, we now put a dot on the 1. Excellent. Okay, it's positive sine, so do we go to a peak or a trough next? Correct. Yeah, peak. Peak, middle, trough. Maybe I should do this in green. Peak, middle, trough, middle. Draw the curve. Okay. It's pretty good so far. One thing that's weird about it though, what do we have left to do? Label the endpoints? I mean, kind of, yeah. Maybe we should have been more specific about labeling endpoints. The answer I'm looking for this one though is the x-intercepts. So we've got y-intercept, that's good. We just haven't done step 7, which is we've got these spots that we haven't done. So how do we find those? Yeah, y equals 0. Yeah, so y equals 0, and the function was 2 sine x plus 1. 2 sine x plus 1. Yeah, this is just rearranging here. So we would subtract 1, divide by 2, gives you sine equals negative a half, which occurs where? Where does sine become negative a half? Not sure? Okay. I'll pull up the unit circle. Well, actually, maybe before pulling up the unit circle, I'll explain how I know what it is. So, I mean, beyond just memorizing, of course, on the unit circle, there's 3 exact values that we know of if we think about quadrant 1. Those are going to be half, root 2 on 2, and root 3 on 2. There's also 3 base angles. Got pi over 6, pi over 4, pi over 3. So this one's the pi over 6, this one's the pi over 4, and then lastly is the pi over 3. Now, when we're talking about sine, we're talking about y coordinates. So if you consider the y coordinate at each of these spots, as the angle increases, y gets bigger. So basically, the way you would organize it would be to say the smallest y value goes here, the next smallest goes there, and the next smallest or I guess in this case the biggest, goes there. So what that tells you is that pi over 6 is the base angle for which sine equals a half. But we don't want sine equals a half, we want sine equals negative a half. Sine being negative occurs in quadrants 3 and 4, these two spots, because that's where the y values are negative on the xy axes. So we just need to figure out what are the pi over 6 type angles in quadrant 3 and 4. Does anyone remember what those are? Have a think about that while I pull up the unit circle for reference. All right, unit circles up. Sorry, what was the question? Yeah, it was what were the pi over 6 type angles in quadrant 3 and quadrant 4? Because we knew it was not just sine is a half, but sine is negative a half, which means we wanted to be in 3 and 4. We knew the base angle was pi over 6, so we know that it's going to be the pi over 6 type angles in quadrant 3 and 4, which if you're looking at your unit circle, either on the screen share or otherwise, that's going to be your 7 pi over 6 spots and your 11 pi over 6 spots, which I have highlighted on the screen share there. Yeah, for where negative a half is, correct. Because you can see both of those things have been highlighted on the screen share. Both of them have a y value of negative a half there. So that's a bit about why, beyond my memorization, that's sort of like why I know where things are. This is literally what I think, which is it's the smallest y value and it's the negative of it. Pi over 6 is the shallowest angle, and I just sort of reflect things in my head. I don't have a photographic memory of the unit circle in my mind, although I might as well at this point. This is the kind of things I do to make sure I don't have to memorize every single thing on there. Do I need to clarify that approach at all? As to like how you can start minimizing the amount of effort you spend on a unit circle? Cool. Okay, so we had 7 pi over 6 and 11 pi over 6, which makes a decent amount of sense if you look at what we got. 7 pi over 6 is just after pi, as we would expect, and 11 pi over 6 is, well, maybe it should be closer here, but, you know, I can't draw perfectly accurately. God knows that. But yeah, slightly before 2 pi. And then, yeah, as you said before, you could label this point if you wanted to be very specific. With the ticks, you kind of handle that, but this makes it bulletproof. Same thing here. If you really wanted to label that, you could. Anything to clarify further there at all for any of that? Otherwise, we can move on to one that has both horizontal and vertical, which I'll start writing out. Okay. Y equals root 2 sine x minus pi over 4 plus 1. Alright, that's down on the paper. I'll have the screen share up on the process. What shall we do? Find period, and period is 2 pi. Yeah. N is 1 in this case, coefficient on x. So capital T equals 2 pi on n, which of course goes down to 2 pi. Very good. What else? A is root 2, yeah. Although, yeah, A is root 2 and minus root 2. you would do plus or minus a, correct, but there's something else that has to be tacked on to that. What has to be tacked on? The 1, yeah, correct. So you've got 1, which is your middle, and then you're plus minusing root 2 from that. So root 2 plus 1, maybe I'll do it backwards here, 1 plus root 2, and then we can have 1 minus root 2. Yeah, 1 minus root 2. When you have these roots, just do a quick rough approximation of what that root should be, because if you don't know that 1 minus root 2 is a negative, you may forget to put it down here. So just be like, okay, root 2, it's going to be somewhere between like 1.4-ish, which obviously is bigger than 1, which is why it goes negative. Yep, that's peaks and troughs. Next up, what do we do? Intervals? Yep. Couple ways we could do this. What could we do? Divide it? Yep. So we have our 2 pi, divide it and add pi on 4 after. Yeah, okay. So you're doing that other. Cool. So you know that your period is 2 pi. To quarter that, so quarter period is therefore going to be pi over 2 if you quarter that one. And then add pi on 4, because that's our horizontal translation. We have a shift right by pi over 4, which means starting at pi over 4, and we repeatedly add these pi over 2s. So that means you have pi over 4 plus pi over 2. This one's a little bit nicer. You don't have to do a full cross multiply. You can just rewrite pi over 2 as 2 pi over 4, and that's not so bad. That's going to get you 3 pi over 4, and then from here, you know you're just repeatedly adding 2's to the numerator there. So 3, 5, 7, 9. That's 1, 2, 3, 4, 5 total things. And none of them simplify. That's nice. So tick, 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 tick. And yeah, 3 pi over 4, 5 pi over 4, 7 pi over 4, 9 pi over 4. All right, that's interval sorted. What else? Y-int. Y-int equals 1. Does the Y-int... Well, what's our domain, actually? Do we need a Y-int? It does say sketch from 0 to 2 pi, so we will need a y-intercept. Yeah. Question now is, does the y-intercept equal 1? I doubt it. So the initial starting value would be 1. Yeah. But for the y-intercept going backwards here, you'd have to sub in x equals 0. Is that fair enough why you'd have to do that? Yeah. So sub in x equals 0 into this. So we've got y equals root 2 sine, it was, 0 minus pi over 4, then plus 1, minus pi over 4, plus 1, y equals root 2 sine minus pi on 4, plus 1. Now sine of minus pi over 4. Anyone know what that was? Or I guess how to handle negative angles? We're getting shorter on time, so I think I'll just pull up the unit circle so you can refer to that if you how to do that. Yeah, maybe this unit circle is still better. Negative pi over 4. What spot does that correspond to? Yeah, 7 pi over 4 spot. So a couple ways you could think about that. One is to just go backwards by pi over 4, so going this direction. The other is to ignore the negative, find where that is on the unit circle, and then flip down from there. Both of those work. So yep, that's a 7 pi over 4 spot, which, because we're sine, means we have negative root 2 over 2 there. So that means we now have y equals root 2 multiplied by negative root 2 on 2 plus 1. Root 2 and root 2 cancel into just 2. Negative 2 on 2 is negative 1. And then negative 1 on 1 makes 0, which, you know, maybe could have seen, but hitting 0 is pretty hard to spot. It's not one of our key features necessarily. But yeah. So that's that. As for the rest of what we need, what else could we start doing? Do the dots and find the x-intercepts. Yeah, precisely. So I'll kind of just work through this one a bit faster pace now so you can leave on time or roughly on time. It's positive sign, so it starts in the middle, then goes to a peak. Maybe I should do green. There it is. Bang, bang, bang. This one's down here, and then this one goes up here. So if you draw all that out, one of the things to keep in mind is that you have to stop. You can't just go straight through here because our domain ends at 2 pi. So it's still good to have that tick there to tick it all out, but we do need to make sure that we stop at 2 pi. Now, I'm pretty sure, just based on the symmetry of things, that 2 pi should be 0, because 0 and 2 pi as spots on an angle on the unit circle should be identical. Let's just double check. So if I put a 2 pi in there, what's that? 4, 8 pi. Yeah, 7 pi on 4. That's the exact same spot. So if you simplified that, that's 7 pi over 4, which we said before was that spot on the unit circle. So this is where drawing the ticks correctly really matters, because this is what I was saying before, which is you have a big wide bit here and then it's like, oh shit, got to cram it in here. So I find this happens a lot with the horizontal translations. With the anything else, it's kind of much nicer because you start with the end and then you halve it. Whereas everything else, if you just tick it freehand, it's a bit whatever. So slight recommendation, maybe use a ruler. That way you can actually have even ticks, but apparently I'm allergic to rulers. That is as complicated as that can get, really. We had to restrict our domain a little bit. So you'd have to give that endpoint there as 2 pi comma 0. And we had to backfill it a little bit. So yeah, we've seen as complicated as these gets. Obviously the numbers can get worse, but as far as the overall process that you follow, you've seen it all. That's about it from me. If you want me to clarify anything else, feel free to let me know. Otherwise, I'll see you in the next one.